Welcome to part 2 of our big Excel project. Let's pick it up from where we left off. And where we left off was we were just struggling with just finishing the formatting on our axis labels. So I'm going to go back in here. When in doubt, we're going to right click and we're going to format that axis. And I'm going to go down to number here. Maybe I don't want all those decimals. This is just a personal choice, and maybe we'd end up changing this based on what we ultimately put in round. But for right now, I'm just going to change that number. I'm going to go into number, and the quick default is 2 decimal places. I suspect that's because Excel is used for financial purposes so much. I think I'll just go to 4 here. Off of that, and I think we're in good shape. Then this tells us size and properties, and that's really kind of how we position things. Maybe you don't have to do this, but maybe we would like to have our labels look like that so they don't run into each other if we get really big numbers here, which can certainly happen in 5th degree polynomials. Okay, what we're going to do next is we're going to determine where the first 0 occurs. Now this is plain old, as you can see, plain old x squared right now. I'm going to go ahead and let's subtract. Let's just put an f term of minus, I'll just go minus 9 for convenience right now. And now we've got these zeros, which we ought to know are 3 and -3, but perhaps they wouldn't be quite as clean as that. So what I'd like our program to be able to do is to detect zeros, and then we'll just have a comment off the side so we wouldn't have to go into our TI and just fumble through it and ask for the zeros. We can just determine what the zeros are. For our purposes now, for simplicity, we're just going to find the first 0 that appears in the domain. So if I had a graph like this and I wanted to know the value of this 0 over here, then I would just have to take my x minimum perhaps and change it to say 1. And now my first 0, this would be the first 0 that occurs on the graph. Okay, so I'll go back, change this back to -6. And here is how we're going to do this. I'm going to go down to where my t-chart is. And I'm going to leave some room in here, but I'm going to create a new, I guess I'm going to put it in I. I think that's enough room for the other things we're going to add. And now, just for good measure, I'm going to put it in J. And I'm just going to put, let's go first 0. Or I'm just going to put 0 because it fits. We'll know what it is. So 0. And now here's how we're going to do this. As I go down and I look at the data in my y, because here's the graph of these are the y values for our parabola that we have. And as I scroll down through that, we will see that we move from 0 from a positive to a negative right in here. You see, we stepped over the actual 0, and the 0 then should therefore be somewhere between -3.009 and somewhere between -2.997. Of course, we know it's -3. So I have to identify when we switch from, and maybe we get a pure 0 here sometime. I have to identify when we switch from 0 from a positive to a negative, or from a positive to 0, or from a negative to a 0 value here. And what I can do over here is I can do this. I'm going to go, see if you can follow this. Equals if, our first if statement, if this value times this value is greater than 0. If it's greater than 0, then I'm either going from a negative to a negative or a positive to a positive if I'm multiplying the 2 numbers. Then I'm going to put in there nothing. Otherwise, I'm going to just put a 1 in here. And the 1 would indicate that we've either one of these 2 values is 0. That would make this product not greater than 0. Or that one of them is positive, one of is negative, that would make this not greater than 0. So here I'm going to get a blank, and I'm just going to replicate that down. Let's make sure it's doing what it's supposed to. Yep, That's testing this times this. And I'm going to replicate this down for the time being just until we actually get a 0. I'm just watching my B column right here for as I cross from positives to negatives. Getting close. And there it happens right in here. And there's my 1. It occurred from here to here, somewhere between. So negative 3.00901 is very close to a 0, but it's probably between these two values. Okay, I'm going to finish that replication, and I have to drag this one out. And I need to take this. I really only need to take this down to the second to last element, but I'll show you what happens if we take it all the way down to here. This last element becomes a 1, but it's not truly a 1 because it's really taking 27 times this blank space. So I really don't want that there. I'm going to delete this one, and I'm going to look at this element. That's the last test for a 0. So as we scroll back up here, watching the B column again, there's a 0, and there it is between 2.997 and 3.009, and then we're going to have another one. Okay, this is going to be some sneaky stuff here. For my 0 test, here's what I'm doing. I'm looking down this column for a 1. Now, I'm going to read right here. I'm just going to put the X chart over here again. You'll see what I'm going to do with this in just a moment. So I'm just going to say cell K101 equals -6. And I'm going to replicate that, which should take me almost all the way down. Because remember, we don't have an element here, but we do have an element there. And then this is a really cool Excel command. I think I'm just going to put it right up above where it says 0 here. I'm going to go equals VLOOKUP. That is vertical lookup. And it says, what value are you looking for? I'm looking for a 1. Where am I looking for it? I'm looking for it down through here all the way to 11, well, actually not really 1100. I'm looking for it down through 1099, comma. Now the column index number is what column, so it looks down for that 1. It's going to find that 1 down there near -3. And then it's basically, if this is column 1, I want to return the column 2 value. I want to return the column 2 value, which is the column right next to it. And I think I want a comma false here. I might have to come back and take a look at that. I can explain that to you if it's a big concern, but I'm going to do that. And we got a bad data field here, so I'm looking for comma 2. Let's take that. Oh, here's the problem. I need this to be through K because J only has 1 column. So in this array, I'm looking for the column 2 entry, and there it is, 3 point, and that's going to be rounded. That's not really what I want. I mean, I'd like it to say exactly -3, and I may not be able to get it. But if you remember, let's go down, take a look at this. Here's our 1. Where's our 1 at here? Did I go down too far? Sorry. There's our 1. So it's just basically returning this value. And it might make sense, because I cross between here and here, to instead of just return this value, return the average of these two values. That might not be exactly right, but it should be closer, because it should, more times than not, it should be closer, because we should be somewhere between there. And again, so this is going to be an approximation of our 0. I'm instead going to say it's at -3.009. How am I going to do this? I want to return that. I want to return its next column. I'm going to save that for another time right now. We're going to leave it at that for an approximation, and I want to come back to that because there's some other things I want to get done on this next section. So up here, because we've got that first 0 located right here, up by our graph somewhere, I'm going to just put it, kind of space this out the way it's going to be when I finish. I'm going to put it right in here. And I'm just going to say first 0. I'm going to make space for that. And I want equals, I want to go down and just grab that x value right here. And so what we have there is that first 0 value. And I'm using a pretty big font here, so it'll be easy for you to have a number of decimals. And again, be aware that's an approximation. If we want a better approximation of it now, I can pin right around that 0. So I'm going to take my x minimum and I'm going to say, let's let you be negative 3.1 and you be negative 2.9. And now we see that it says negative 3, but maybe it's not even exactly negative 3, but it's so close that it's rounding to that. So we could narrow down our zeros pretty quickly that way. Negative 6 to 6. Again, we're only finding the first 0 that occurs in our given domain. If I want to find this 0 over here, I could note, hey, look, it's somewhere between 2.4 and 3.6. So I could just go 2.4. And as soon as I do that, it recognizes that next one. If I want to get closer to it, I can say, well, it's between 2.7 and 3.1. So 2.7 and 3.1. And now it's recognizing, hey, 3 is probably where it is. So pretty slick for us. Okay, let's talk about some other things that we're going to do with this function. I'm going to go back to negative 6 to 6. Really cool function down there. That VLOOKUP is really useful for us in a lot of situations within Excel. Okay. All right, so we have our tangent line. It would probably be nice if we had that tangent line and just had an equation of the tangent line. Now I know we could look at that tangent line and say that, well, we've got an ordered pair, 2, -5. We've got a slope 4. So I know that with the equation, the line could be y plus 5 equals 4 times quantity x minus 2, and I could just point slope that in my head. But how about if we just turn that into a y equals? So I'm just going to use some space right here just to get a thought in my head. So this is just scratch work right here. So it's the y minus the y coordinate equals slope times quantity x minus the x coordinate. Or that would be y equals slope times, in fact, I'm going to do it this way, I believe. Yes, I am. I'm going to go slope times the x value minus slope times the x1 value and plus the y1 value. I will be right back with you in just a moment. Okay, thank you. So from there, I'm going to kind of try to think through what our slope-intercept form is going to look like. This is really the equation for slope-intercept form because this x1, y1 are going to be these equations. So the big challenge with this is that we're going to have maybe a minus negative, and we can come back and talk about that, but I'm just going to temporarily, I'm going to put this in here. I'm going to go equals, quotations. It's always going to start with y equals. I'm going to put a space in here. So this is the beginning of my equation. And then I'm going to do what's called concatenating. I'm going to put in, the next thing I want to put in is my slope times x. So that is, the next thing I'm putting in here, I'm going to make this big so we can see it. For the time being, I'm going to take this off. I'm going to come back here. I'm going to make this guy big. So it's y equals, and the next thing I want to appear there is my slope, and that is this. And I want that to be times x, so I'm going to concatenate. The next thing after that is going to be, back in quotes, an x. It's just going to be that text. Now, the next thing I would put after that, I'm going to go space, is a space minus and a space in end quotes. Now, we got the chance of having a minus negative here. Okay, after that, concatenating, chunking things together. The next thing I want is mx1, or m, my slope, times my x1 value, that is here, and I want plus my y1 value, that is here. And there is my equation. Now that's a really pretty simple equation, but it's going to get uglier if I do something like 1.73. It's going to get quite a bit uglier. And now you see that we have this minus a negative, and that's an issue we can come back and talk about. This is a really good time for us to talk about our round feature right now, because you see we get some ugliness in this solution right here. So I'm going to set my round for right now to 3 decimal places. And here's what I'm going to do. In this concatenate statement, any place where I have a number, and there's a number right here, I'm going to surround that with round that number to the number of digits that. This is going to be a number. Round this to the number of digits that. And now if I hit enter, I get this. Now I still have some challenges with this minus negative, but for right now we're going to live with that. When you take a quiz on this, I'm going to ask for the slope intercept form. Maybe I'll give some extra credit if you could figure out how do we determine and put a plus in there. It's going to involve some if statements. It's pretty clever stuff. So anyway, we might do something like, I'm going to take these off. I might do something like, it's pretty clear that's our tangent line, but maybe I would want to put something, maybe equation of tangent right here. Okay. If I go back now just to test and say we chose an x value of -5, there's my equation of our tangent line. If I chose an x value of -3.1076, it's smart enough to know we're rounding to 3. Take a look at this. What if I want more accuracy? Well, let's round it to 4. Let's round it to 1 decimal place. So pretty nice control over that thing. Okay, I am going to stop this short video at this point right now. I've got a student coming in, and I will get back with you. I'm trying to do these in 30-minute bits, but this one's going to get stopped right now. So this is 2. This is example 2, or part 2. Tune into part 3.